Hi everyone and welcome to our module on the large intestine. In this module, we're talking about the various aspects of the anatomy of the large intestine. We'll start with gross anatomy of the large intestine, then we'll follow that up with the histology and the embryology, and then finally we end up with the clinical significance of the large intestine. The large intestine is an organ that is part of the GIT. The GIT simply comprises of organs that ranges from the mouth all the way up proximally to the anus distally. So it spans the mouth, the pharynx, the esophagus, stomach, the small intestine, and then in between the small intestine and the anal canal is the large intestine. It comprises of three major parts. This includes cecum, the appendix, and the colon. The entire length of the large intestine is about 1.5 meters. It extends from the ileocecal valve, that's the point where the ileum, which is a part of the small intestine, ends, to the rectum, which is the end of the sigmoid colon. It tends to be separated from the small intestines by a number of four major features. So these four features, once we see them, we tend to identify the large intestines in comparison to the small intestine. So what are these features? Number one, the diameter. There's a reason why it's called large intestine. The reason why it's called large intestine is because it, in terms of diameter, it is larger than the small intestine. Aside that, we also have a very unique structure found in the middle part of the large intestine known as the tinea coli. It's a combination or collection of muscle structures that forms this unique feature. And this is the tinea coli shown in the image here. It's the central part of the large intestine that comprises of longitudinal muscles that are arranged in that particular fashion. Then we have the third feature that separates the large intestine from the small intestine is being the omental appendages, also called the epiploic appendages. So these are fatty like substances found at the edges of the large intestine. You can see some of them shown in the image here. You can see some fatty structures popping out of the sides. These are what we call omental appendages. And then finally, we have the fourth feature being the presence of circulations or ostrations. So ostrations are these pouches that we see forming the contours of the large intestine. You can see the large intestine is not necessarily straight. It forms multiple contours as I'm outlining here. These contours are known as ostrations or circulation. So once we see any of these four features, then we could easily identify the large intestine and separate it from the small intestine. Usually, the ones that we tend to can pretty much easily appreciate would be the tinea coli and the omental appendages. The other two, it takes a skilled anatomist to be able to distinguish the small intestine from the large intestine using the other two features, which would be the large diameter and the presence of circulations or ostrations. What is the function of the large intestine? It is present as part of the GIT for the function of absorption of water. Aside that, it's also involved in the conversion of indigestible residue into semi-solid stool or fecal matter. So where we get fecal matter usually stems from or arises from the large intestine. So food substances that were not easily digestible, broken down, or absorbed into the body in the small intestine will be converted to fecal matter in the large intestine. And then finally, the large intestine will now serve as a form of temporary storage for the fecal matter until the point of defecation, until we're ready to defecate and excrete out the fecal matter. Jumping into the gross anatomy of the large intestine, we'll talk about the different components of the large intestines in terms of their gross anatomy. We'll start with the cecum, we'll move to the appendix, and then we'll end with the different aspects of the colon. Starting with the cecum. The cecum is the part of the large intestine that is regarded as an intraperitoneal portion. So large intestines tend to have both retro and intraperitoneal parts to it. The cecum tends to be intraperitoneal because the peritoneum tends to surround the entire cecum. So unlike other aspects of the large intestines like the ascending and descending colon, those ones are retroperitoneal. Those ones would have the peritoneum surrounding only the anterior surface. The cecum has the peritoneum surrounding its entire structure. It's the most proximal portion of the large intestine. So when we talk about the large intestine as a continuation of the small intestine, the very first structure we start with will be the cecum. It is located in the right iliac fossa. It tends to ascend or extend to become the ascending colon. So it extends between the ileum and the ascending colon. And then finally, in terms of its measurement, it measures about 7.5 centimeters in length. The cecum, although it is intraperitoneal, it's important to note that it lacks a mesentery. So it's surrounded by peritoneum but doesn't have a mesentery that anchors it to the posterior abdominal wall. And that's very important to know. Moving on to the second part of the large intestine, which is the appendix. The appendix is also an intraperitoneal structure, just like the cecum. It is found at the posteromedial aspect of the cecum, just below it, and you can see that the appendix tends to form like a tail-like structure at the end of the cecum. So we can say that the appendix is kind of like the tail of the cecum. It is really referred to as the appendix because it has no known function. So the appendix, when you hear appendix or appendage, is just an additional structure without any known function. So we don't really know what the appendix does in the body. We just know that it is part of the large intestine. Um, Other things to note about is the fact that although it is intraperitoneal, just like the cecum, it does have a mesentery. So the cecum doesn't have a mesentery, but the appendix does have a mesentery. The mesentery of the appendix is a triangular shaped mesentery, also called a mesoappendix. Then finally, in terms of its length, is about 6 to 10 centimeters in length. It's longer than the cecum, and most importantly, the appendix tend to vary in terms of location in the abdomen. So we have different forms of positions in which the appendix could be in. And we'll talk about that in the next slide. We see a picture that shows the different forms of positions that the appendix could be in. So this image depicts for us the different positions of the appendix. There are majorly 5 types of positions that we could find the appendix in whenever we are dissecting a cadaver, or we are doing surgery. Maybe we're doing a surgery on the appendix, like an appendectomy. We could meet the appendix in any of these 5 different positions. So they include the posterior position, also known as the 1 or 2 o'clock. So it's pointing towards the ileum. That's why it's called the post-ileum. But it's behind it. So the post there shows that it is behind the ileum. Then we have the pre-ileal position. That this one is also pointing towards the ileum, but it's in front of the ileum, and that's also the 1 or 2 o'clock. So depending on whether it is in front or behind the ileum, we could describe this position as either being post or pre. Then we have the pelvic appendix. Pelvic appendix is an appendix that is located within the pelvis. That's dropped into the pelvic cavity. Then we have the subcecal appendix. This is one that is found just directly below the cecum. It's not in the pelvic, it's just already sitting below the cecum. And then finally, we have the retrocecal appendix. The retrocecal appendix is the 11 o'clock. It's found directly behind the cecum. Please do note that the most common position out of all these 5 positions will be the retrocecal position. It's the most common position to find the appendix in when we are dissecting the cadaver or performing surgery. Let's talk about the colon. The colon is the longest part of the large intestine. It's the top part. It extends from the termination of the cecum all the way to the rectum, and it has 4 major parts. So what are the 4 parts of the colon? They include the ascending colon. The ascending colon in green, you can see it's the starting point that is a continuation from the cecum. Then the transverse colon in yellow, then the descending colon in blue, and then finally we have the sigmoid colon that will eventually terminate into the rectum. Let's talk about the different parts of the colon, starting with the ascending colon. It's the first part of the colon. It's therefore is in direct continuation with the cecum. It is secondary retroperitoneal in classification, and this is in contrast to the cecum and the appendix that we just talked about. Remember that the cecum and the appendix are intraperitoneal structures. The ascending colon, whereas, is called a retroperitoneal structure, but specifically secondary retroperitoneal. I'll talk about why it is called secondary retroperitoneal. But for a structure to be retroperitoneal, it means that the peritoneum must be surrounding the anterior surface of that structure, and there will be no peritoneum lining the posterior surface, and that's why we call it retroperitoneum. So it is behind the peritoneum. In terms of location, the ascending colon is found in the right lumbar region, and it extends from the cecum all the way to the transverse colon. Between the transverse colon and the ascending colon is a junction. So that junction is known as the hepatic flexure or the right codic flexure, and it's a very important junction where blood supply tends to transit from the blood supply of the ascending colon to the blood supply of the transverse colon. Also, the ascending colon is related to a space just at the sides, just lateral to it, known as the right paracolic gutters. And this is just very important to note. One more thing to note about the ascending colon is the fact that about 25% of population tends to have an ascending colon that contains a mesentery. So 25% of population has an ascending colon that actually is intraperitoneal, but majority of people would have an ascending colon that is retroperitoneal. The second part of the colon is the transverse colon. The transverse colon tends to span the ascending colon and the descending colon, so it runs horizontally between those two other aspects of the colon. It is intraperitoneal, unlike the two other colons, as the ascending and the descending. So just like the cecum and the appendix, transverse colon is also intraperitoneal. And just like the appendix, the transverse colon also has its own form of mesentery. It has a very large mesentery known as the mesocolon. That mesentery anchors the transverse colon to the posterior abdominal wall. In terms of location, it is located in the epigastric region, and it is connected to the stomach and the diaphragm. So the stomach is connected to it through the greater omentum, and then to the diaphragm, it's connected to it through the phrenicocholic ligament. Remember that it extends from the ascending colon to the descending colon. So between the ascending colon and the transverse colon, we have a junction. That junction is known as the right colic flexure or the hepatic flexure. I talked about it when talking about the ascending colon. And between the transverse colon and the descending colon, we also have another junction. That junction is known as the left colic flexure or the splenic flexure. So it's important to note that. And then there are also spaces that are found above and below the transverse colon, just like we have spaces found lateral to the ascending colon. Remember, the space found lateral to the ascending colon is the paracolic gutters. The space found above and below the transverse colon will be called the supracolic and the infracolic spaces. So just quickly remember that. We talked about that when talking about the entire abdomen in terms of the peritoneum of the abdomen, but just to remember that in relation to the transverse colon. Let's talk about the third part of the colon, which is the descending colon. It is also secondary retroperitoneal in classification, just like the ascending colon. So it has peritoneum that is surrounding it anteriorly, but not posteriorly. It is located in the left lumbar region, so it's just homologous to what we see on the right side of the abdomen. And then finally, it extends from the transverse colon above it to the sigmoid colon below it. So between the transverse colon and the ascending colon, we have a junction known as the splenic or left colic flexure. Also note that lateral to the descending colon is another form of space. Mirrors what we see on the right side, known as the left paracolic gutters. And just like the ascending colon, about 33% of population usually have a descending colon that contains a mesentery. So remember that it's not in all scenarios or in all states that descending colon is retroperitoneal. We have a few people that have a descending colon that actually do contain a mesentery and is intraperitoneal. The last part of the colon is the sigmoid colon. It is an intraperitoneal structure. So just like we had the transverse colon being intraperitoneal, the sigmoid colon is also intraperitoneal. It has a mesentery similar to what we see in the transverse colon as well as the appendix. The sigmoid colon mesentery is a V-shaped mesentery that tends to surround it and anchor it to the posterior abdominal wall. The sigmoid colon is located in the left iliac fossa or the left iliac region, just like the cecum, and it tends to extend from the descending colon above it down to the rectum just below it. What's the blood supply of the different aspects of the large intestine? The cecum is supplied by vessels that tend to be continuations of the blood supply to the ileum. These vessels are known as ileocecal vessels. Then we have the appendix having special supply coming from the ileocecal vessels. These vessels are known as appendicular vessels. For the colon, each of the colon will be supplied by different forms of vessels that comes either from the superior mesenteric arteries and veins or the inferior mesenteric arteries and veins. So just for us to note, the ascending colon and the transverse colon are supplied largely by vessels coming from the superior mesenteric vessels. And it makes a lot of sense because superior mesenteric vessels supplies the structures of the midgut. The ascending colon and part of the transverse colon are structures of the midgut. Then the descending colon will be supplied by the descending colon and the sigmoid colon will be supplied by vessels coming from the inferior mesenteric vessels. Remember that the descending colon and the sigmoid colon are derivatives of the hindguts, and the hindguts supplied largely by the inferior mesenteric vessels. To be very specific about the different vessels supplying each of the structures, the ascending colon is supplied by the right colic vessels, the transverse colon is supplied by the middle colic vessel, the descending colon is supplied by the left colic vessel, and then finally the sigmoid colon is supplied by the sigmoidal vessels. Here's a picture showing us the blood supply of the different aspects of the large intestine. You would notice that the inferior mesenteric artery is shown here, and you can see some of the branches of the inferior mesenteric artery supplying the descending colon and the sigmoid colon. You would also notice the superior mesenteric artery above it, and some of the branches coming out of the superior mesenteric arteries will be supplying the transverse colon alongside the ascending colon, the cecum, and the appendix. In terms of the venous drainage of the large intestine, a venous drainage also stems from the superior mesenteric vein and the inferior mesenteric vein. And these veins tend to eventually end up forming the portal vein. The inferior mesenteric vein joins into the superior mesenteric vein. Then the superior mesenteric vein will join the splenic vein to form the portal vein, and the hepatic portal vein will drain into the liver. So some of the venous supply, or most of the venous supply coming from the large intestine, would end up in the liver for filtration and eventually being transferred into the inferior vena cava, or the IVC. Let's talk about lymphatics. Lymphatic drainage of the colon comes from a number of different lymph nodes. This includes the idiosical lymph nodes for the cecum and the appendix, and then the superior and inferior mesenteric lymph nodes for the colon. Then finally, the nerve supply to the large intestine comes from the combination of the superior mesenteric plexus and the inferior mesenteric plexus. The cecum, the appendix, and part of the colon will be supplied by the superior mesenteric plexus, usually the part of the colon that is formed from the midgut. And then finally, the inferior mesenteric plexus will be supplying structures that are derived from the hindgut. So structures like the descending colon, sigmoid colon. Let's talk histology. The large intestine is made up of a lumen, and that lumen is of variable diameter. The lumen is surrounded by a wall, and for us to understand the histology, we need to talk about the different tissues that makes up the layers, or the layers of wall of the large intestine. There are usually four main layers formed by different forms of tissues. This includes the mucosa, that's the innermost layer, the layer that is in direct contact with the lumen. Then the submucosa, then the muscularis externa, then finally the serosa. Mucosa is the innermost layer of the large intestine. It comprises of three major sublayers. Starting from the innermost layer to the outermost layer, we have the epithelium. The epithelium of the mucosa of the large intestine is unique because it is simple columnar in form. This is a similar epithelium that we see in structures higher up, that is higher above the large intestine. So in the small intestine and the stomach are also lined by simple columnar epithelium. Then we have the lamina propria that contains a number of connective tissues. And then finally, we have the muscularis mucosa, which is muscle structures that are present within the mucosa. So there's some important modifications that we tend to see in the entire large intestine that tend to mirror what we see in the small intestine. So microscopically, when we look at the epithelium of the large intestine, or the mucosa of the large intestine, we'll notice that there are invaginations formed by the mucosa of the large intestine. These invaginations are known as the crypt of Lebercon. We talked about them when we talked about the histology, the mucosa of the small intestine. We also see them in the large intestine. These crypts are lined by different types of cells. These are cells that would eventually form the epithelial structure of the large intestine. They include the colocytes. Colocytes are practically the counterparts, or the homologous structures to the enterocyte that we see in the small intestine. They are the simple columnar epithelium that we described as the major epithelium that lines the large intestine. So they make up a large chunk of the epithelium of the large intestine. Aside the colocytes, we also have some other smaller cells that do minor roles in terms of the physiological function of the mucosa. This includes cells like goblet cells. Goblet cells are involved in the secretion of mucus into the lumen. And then we have stem cells. Stem cells are involved in the reproduction of progenitor cells are involved in the reproduction of newer epithelial cells, particularly the colocytes. So the colocytes, once they undergo wear and tear and are destroyed, they usually get replaced by the stem cells. Then we have the enterochromaffin cells. Enterochromaffin cells are cells that are also lining the crypts, that are involved in secretion of a number of different hormones. So the second histological layer of this large intestine is known as the submucosal layer. It's the layer just directly beneath the mucosa. It is composed of dense connective tissue that is made up of a number of structures, including collagen, elastin, blood vessels, and lymphatic vessels. And it usually contains a very specialized form of nerve tissue known as the Meissner's plexus. This is also what we see all across the entire GIT that helps it in the stimulation of glands and the secretion of different substances into the lumen of the GIT. The third histological layer of the large intestine is the muscularis externa. It's the thickest layer. It's composed of two major layers of smooth muscle. This includes the inner circular smooth muscle and the outer longitudinal smooth muscle. Please do note that the outer longitudinal smooth muscle um, of the large intestine tends to gather to form a separate longitudinal band of structure known as the tinea coli. Remember, the tinea coli I mentioned as one of the major characteristics that we use in distinguishing the large from the small intestine. That tinea coli is gotten from the outer longitudinal muscle. They gather together, form a single band, and they run through the entire large intestine from the cecum all the way up down and down um, towards the sigmoid colon. We don't see tinea coli in the appendix. It's important to know that, and we also don't see it in the rectum. We don't see it in the rectum because the rectum is not part of it's not considered part of the large intestine in terms of the three major structures we already mentioned, and we don't also see it in the appendix for several reasons. So, where we do see tinea coli would include the cecum, the ascending colon, transverse colon, descending colon, and the sigmoid colon. Aside the tinea coli being a very, very important structure found in the muscularis externa, we also have specialized nerve tissues that are similar to the ones we see in the submucosa, known as the Albrecht plexus. So Albrecht plexus would be the nerve tissues present between the inner and outer muscle layers of the muscularis externa. And the function of Albrecht plexus is to stimulate the muscles for peristaltic movement, for contraction. And so the same way in which we have the Meissner's plexus stimulating the glands for secretion, we have the Albrecht plexus stimulating the muscles for contraction and peristalsis. Now, the final histological layer of the large intestine is known as the serosa. So serosa, although is found throughout the entire large intestine as the outer layer, in some certain areas we have the serosa being replaced by an adventitia. Now I'll explain why. So typically, when we talk about intraperitoneal organs of the large intestine, like the colon, the cecum, and the appendix, and then the sigmoid colon and transverse colon. That's specific those two aspects of the colon. These four major structures are surrounded entirely of they have their outermost layer being formed entirely by serosa. All right. The exception to the rule tends to be in the retroperitoneal organ. So the retroperitoneal organs, the ascending colon and the descending colon, only has the anterior portion being lined by serosa, whereas the posterior part tends to be lined by adventitia. That's the distinction we need to know. So please do note, serosa is found throughout the entire um, histology of the large intestine as an outer layer, but in certain areas we have that serosa being replaced by adventitia, and that is specifically the posterior wall of the retroperitoneal organs. Serosa tends to be characterized by small pendulous protuberances of adipose tissues that are known as omental or epiploic appendages. I mentioned that as part of the features that tend to distinguish the small intestine from the large intestine. If you see it, you automatically can identify the structure as being the large intestine. Let's end this segment by talking about embryology. Embryology of the large intestine coincides with the embryology of the small intestine. The reason is because the large intestine is partly derived from the midgut and partly derived from the hindgut. So we'll talk about the development of the large intestine in terms of those two areas. We'll talk about development from the midgut. We also talk about development from the hindgut. So usually development tends to begin from the sixth week of intrauterine life for both the midgut development and the hindgut development. We'll dive in deeper from there. Starting with the development within the midgut tends to first of all elongate at around sixth week, and then this elongation will eventually lead to it being um, too large for the entire abdomen. It elongates first of all to form a U-shaped loop known as the midgut loop, and around the sixth week, once the elongation occurs, the entire size and structure of the midgut becomes too large for the abdomen, and that will lead to the next four phases occurring. So the first next four phases occurs as a result of this increase in size relative to the abdominal abdomen or abdominal cavity size that we see. So these four phases includes the phase of herniation. So the midgut loop of the intestine would herniate into the abdominal anterior abdominal wall. Then rotation, there will be rotation occurring within the anterior abdominal wall, and also rotation occurring during return. And then finally there's return. So the with time, when the abdominal wall or the abdominal cavity expands in size, the midgut loop will eventually return back. And then finally, there's fixation. Fixation just is what occurs to certain aspects of the midgut loop, which we'll talk about very soon. So let's start with herniation. Herniation is, like I said, as a result of of an increase in size or of the midgut loop relative to the size that is available for it in the abdominal cavity. So the midgut forms this U-shaped loop and then finally herniates through the primitive umbilical ring into the extra embryonic cilium. And this type of herniation is usually known as a physiologic umbilical herniation. Is expected to occur. It is not something that is pathologic in the sense that something that is as a disease in a sense. It is expected to occur as part of the normal development of the midgut. So when the midgut herniates into the anterior abdominal wall, the loop begins to rotate. So it rotates while it is present within the anterior abdominal wall and also rotates while it is returning. So please do note, rotation occurs twice. So the first rotation is rotation occurring within the umbilical cord, within the anterior abdominal wall. So that rotation is known as the 90 degrees counterclockwise rotation. So once it rotates 90 degrees counterclockwise, it brings the cranial part of the or the proximal part of the midgut loop. It brings it to the right, which was initially cranial. So imagine it going from cranial to the right side, and then the caudal part, that's the part that is lowermost portion or the distal part, is being brought to the left. So please do note that once there's a 90 degrees rotation of the midgut loop while it is still within the umbilical cord, the cranial part or the cranial limb is moved to the right. The caudal part of the caudal limb is moved to the left. Please do note some of these terminologies are very important to remember. Caudal limb will give rise to structures that we'll talk about. Then the cranial limb will also give rise to structures that we'll talk about. In terms of its rotation, it tends to rotate on the axis of the superior mesenteric artery, and this rotation needs to be 90 degrees counterclockwise. If we have a rotation that is 90 degrees clockwise, you could have a mal-rotated midgut, and that could lead to obstruction of the superior mesenteric artery. So once that first rotation occurs around the 10th week, the abdomen expands in size and can now accommodate the increased size of the midgut loop. Once this occurs, we need the midgut loop to return back into the abdomen. So return of the midgut loop into the abdomen is one of the four processes that occurs during embryology. The first aspect of the midgut loop to return is usually the cranial limb. Remember the cranial limb, that part that tends to rotate to the right side after the 90 degrees counterclockwise rotation. So that part returns first. So it returns, passes posterior to the superior mesenteric artery, and then occupies the central part of the abdomen. And that cranial limb, please do note, eventually gives rise to the small intestine. So we don't really talk about it in this particular module because of the fact that it was already discussed in the previous module in terms of the small intestine. The caudal limb is our major focus. So the caudal limb returns next, and as the caudal limb is returning towards the abdomen, it undergoes a secondary rotation. So the first rotation occurred while it is present within the umbilical cord. So both the cranial and caudal limb rotated. But when the caudal limb is returning back, it tends to have its own unique rotation. And that rotation is about 180 degrees counterclockwise rotation. So in total, we say that the entire midgut rotates 270 degrees counterclockwise. The caudal limb returns while rotating and then eventually occupies the right side of the abdomen. And that's very important to note. It rotates to the right side of the abdomen and eventually to give rise to the part of the large intestine we'll talk about in terms of the derivatives. The final aspect of the embryology of the midgut tends to be the point of fixation. So fixation is practically the attachment of the midgut to the posterior abdominal wall. So the attachment of the dorsal mesentery to the posterior abdominal wall tends to be greatly modified after the intestine has returned. So at first, usually the dorsal mesentery tends to be in the medial plane, and as the intestine tends to enlarge, lengthen, and assumes its final position, the mesentery will eventually be pressed on the posterior abdominal wall. And this pressing of the mesentery on the posterior abdominal wall will lead to some of the mesentery being lost because the mesentery will fuse to the peritoneum just directly behind it. And this is very important because of the concept of what we call secondary retroperitoneal structures. Remember, I said that in terms of the midguts, first of all, the midguts gives rise to the cecum, the appendix, the ascending colon, and parts of the transverse colon. So please do note that when the midguts, the caudal part of the midguts returns back to the abdomen, the dorsal mesentery that tends to surround that ascending colon is what gets fused to the posterior abdominal wall. The other mesentery of the transverse colon or the cecum and the appendix tend to still be they tend to still retain their dorsal mesentery and eventually tend to still be present. Um, Now, why I brought this up is because of the fact of the concept of secondary retroperitoneal classification. We say the ascending colon is a secondary retroperitoneal structure because initially, when its embryonic structure was being formed, it actually contained a full peritoneal mesentery surrounding it. So it was initially intraperitoneal. But during the process of embryology, during the process of fixation, we had the ascending colon losing its mesentery and eventually becoming retroperitoneal. So we say it's a secondary retroperitoneal because it was initially primarily an intraperitoneal organ. I hope you understand what I mean by that. Just a few things before we move on to the development of the other aspect of the colon, which is from the hindgut. The cecum, once the cecum um, um, as the cecum is being formed, usually the cecum is the first part of the midgut to be formed. It appears around the sixth week as an elevation of the anti-mesenteric border of the caudal limb of the midgut. So it's the first portion of the caudal limb that develops. How we know it is developing is that we have a part of the midgut swelling more than the rest, and that part that swells is known as a cecal swelling. So it swells, but a part of it doesn't grow so well, and that part that doesn't grow so well, it tends to eventually become the appendix. So the appendix is just a portion of the cecal swelling that fails to develop compared to the rest of it. So let's say we have let me see if I can illustrate. Let's say we had the the collar part of the midgut being a single uniform structure like this. A part of it in terms of its terminal end would swell as like a bulge. That part that we see swelling is known as cecal swelling. But as it's swelling, there's a very tiny part of it that doesn't fully develop. Well, usually that portion is usually the apex. It doesn't fully swell. So it just maintains that. So the part that doesn't fully swell, also called the apex, will become the appendix. And the part that forms that swelling itself will become the cecum. And that's what we tend to see in terms of the development of the cecum and the appendix. Let's talk about the development of the part of the colon that is derived from the hindgut. Remember that the hindgut will give rise to terminal structure of the GIT, including the descending colon, part of the transverse colon, sigmoid colon, the rectum, and the anal canal. So do note that in terms of the development of the hindgut, the part that is going to give rise to the colon is the cranial part of the hindgut. So the cranial part of the hindgut develops into the rest of the colon. The junction between the segment of the transverse colon derived from the midgut and that originates from the one from the hindgut tends to indicate a change in blood supply, as I'll talk about very soon. But do note that in terms of the hindgut, what the hindgut eventually would form would be the distal portion of the transverse colon, the descending colon, the sigmoid colon, and eventually the rectum and the anal canal. So our major focus would be the first three, or the first three. So please do note the transverse colon, the proximal one third of the transverse colon is got from the midgut. The distal, the proximal two third, sorry, of the transverse colon is gotten from the midgut. The distal one third of the transverse colon is gotten from the hindgut. So between the proximal two third and the distal one third, we have that junction that is being spoken about in this slide. So the junction is marked by a change in blood supply. Usually, the proximal two third of the transverse colon, the part gotten from the midgut, is supplied by the superior mesenteric artery, whereas The distal one third of the hindgut of the transverse colon, the part that is gotten from the hindgut, is supplied by the inferior mesenteric artery. Also note, just like how we had the aspect of the midgut eventually fusing to the posterior abdominal wall, we also have aspect of the hindgut also fusing to the posterior abdominal wall. So that tends to be the descending colon, the part that is formed, the part that forms the descending colon would have its mesentery fusing with the posterior abdominal wall, and eventually it becoming secondary retroperitoneal in form. So, in to wrap up this aspect of the embryology, let's talk about the derivatives of the entire large intestine in terms of the embryologic structures. So, midgut wise, the caudal part of the midgut will give rise to the cecum, the appendix, the ascending colon, and the proximal two-thirds of the transverse colon, as I mentioned. And then finally, in terms of the hindgut, the cranial part of the hindgut gives rise to the distal one-third of the transverse colon, the descending colon, and the sigmoid colon. So, one very important clinical significance to the subject of the large intestine would be in the condition known as appendicitis. Appendicitis is simply the inflammation of the appendix. It's very important to note because of the type of clinical features we see. Some of those clinical features were addressed when talking about the anterior abdominal wall. Remember that we have particular points in the anterior abdominal wall where we could feel for the maximum tenderness of an inflamed appendix known as the Labrinus point. Besides that, it's also a very important condition because of the level or amount of surgeries being done in terms of the removal of the appendix. Why this is anatomically relevant is because the appendix doesn't really have a known function. So removing the appendix will not really do anything in terms of the function of the entire large intestine because it's practically a vestigial structure. And that concludes our module on the large intestine.